I want to give a high-level overview of some of the core components that make up Project Babbage and some of the solutions that we've created for the MetaNet. At a high level, I would say there are just a few core components that come together to make a fully working and cohesive set of technology, including things like the MetaNet Client, Auth-Write, Packet Pay, Dojo and Ninja, NanoStore, Tokenator, PeerServe, Confederacy, and a few others. But I won't get into a lot of detail here. This is just a high-level overview because chances are you don't know what at least a few of those things are, even if you might be working on this project. So even members of my own team might be focused on other areas, and especially just for those who don't know what is the MetaNet and what is Project Babbage, I just want to, give a high-level explainer about each of these components. So let's zoom all the way out. What is the problem that we're trying to solve? The problem that Project Babbage is trying to solve on the MetaNet is we want to make it 10 times faster for people to create blockchain-powered applications that put the users at the center, improve the privacy of users, and enable micropayment functionality within those types of applications. So our goal is to make it 10 times faster for you to make apps that put people at the center, improve their privacy, and allow them to pay for things directly, right? That's like the elevator pitch of Project Babbage or something, right? So starting with this goal, what have we done to make this happen? Well, users need a way to interact. They need a way to touch the blockchain and actually create transactions and have the ability to sign things and unlocking scripts in Bitcoin, because Bitcoin, you have inputs and outputs. You have outputs that are locked using programs that need to be unlocked, and only a certain user can unlock that. Therefore, users need to have keys. Users need to have keys because they can use those keys to deal with Bitcoin. That's how that works. That's why users need keys in Bitcoin, right? They need to be able to interact with the programs that run on the Bitcoin blockchain that govern their money and how it can move, or the things that is represented by tokens inside of Bitcoin outputs, right? And the UTXO model of Bitcoin. Anyways, getting ahead of myself. Core components, big picture. Why are we here? What is all of those things that I just said? Let's start with users, right? Users need keys. Okay, we've established that. So users need a way to manage their keys. They need a program to run on their computer or in their phone or some other way that they can have keys so that they can deal with Bitcoin. So they can make Bitcoin transactions, so they can sign things. You can create digital signatures when you have keys, and you can encrypt data to exchange things privately when you have keys. And so really, keys allow privacy by exchanging information between users and digital signatures at a low level. And then what this enables at a high level is you can use these digital signatures within Bitcoin transactions to secure Bitcoins. You can also use these keys to create systems that allow different applications to plug into the same keys in the same ways across different users in such a way that protocols get designed so that the users have information that is theirs, right? So the user has the one set of keys. Different applications can all plug into that same user and put the user at the center, right? So when I say put the user at the center, I mean like you have a web browser. You can visit any website with that web browser, and then you don't have just one web browser. You can use any. You can use multiple. So the user is free to use whatever system they want. So just like web browsers, you can move between web browsers if you want. We want to make that the case for every application. So micropayments, privacy, putting the user at the center, these open data protocols for user data, and then things like that. So what enables that, right? What is the MetaNet Client? The MetaNet Client is that piece of software. It runs on the user device, on their phone or their computer, and it puts them at the center. It has their keys and it has their transactions in Bitcoin, and any app can talk to the MetaNet client over a standard interface, and that interface is in between the applications on the MetaNet and the clients on the MetaNet, right? So there's a standard application to wallet interface, and that is the interface by which applications can talk to MetaNet clients, and there can be many MetaNet clients, so we're not the only one. We don't want to be anyways in the long term, and many applications, and they can all be compatible because there's a standard interface. So MetaNet clients are what users use to create transactions, to manage their keys, to maintain their privacy, and then when certain applications talk to the MetaNet client, they try to use certain classes of user data. So for example, I might have data associated with the songs that I like to listen to, and that might be my tempo protocol data inside the tempo app. Or there might be data associated with my to-do list or my diary or my social network or whatever it is. So users also manage permissions in the MetaNet client, because a certain app now, just like on your iPhone, all the apps, they all plug into your location. This app would like to use your location. Well, now it's like that only for every type of protocol and every type of data. And this means the MetaNet client pops up with permission dialogues, just like how, an operating system might on a mobile device or whatever. And essentially, it just lets the user manage permissions. Which apps get to do which things with which types of my data. That's what the MetaNet client sort of enables the user to have control over. So users, when they use a MetaNet client, they get control over which apps get to do what and for how long, right? So which apps get to spend how much of my money over the next 1 month? Or which apps get to access my list of friends? Or which apps get to know my real name or my zip code or something like that? As endorsed by a certifier. So certificates come into this a little bit, where certifiers are people who attest to the validity of something like your zip code. And then when some app trusts that information, they can send that through the MetaNet client as well. But that's essentially the MetaNet client. So that's number one, right? That allows users to create Bitcoin transactions that allow applications to plug into the user identity. It allows users to be in control. So there were a lot of other systems that I talked about, though. I talked about Dojo and Ninja. So we'll start there. Okay, Dojo and Ninja is a system for processing Bitcoin transactions, managing Bitcoin transactions. In fact, the MetaNet client uses Dojo and Ninja under the hood to allow users to manage their Bitcoins. So Dojo and Ninja is a Bitcoin manager, but the MetaNet client uses it. So the Dojo and Ninja system is a dependency of the MetaNet client. And it can also be used outside the MetaNet client for things like, so suppose I'm a server-side application, right? I run an API, and I want to maybe have a Bitcoin exchange or something, and I want to make sure that the transactions that I'm dealing with when I send money out in Bitcoin to certain people or use certain Bitcoin token protocols, or when I receive money in from certain people, I want to be able to verify the legitimacy of those coins. And so the Dojo and Ninja system allows for this to happen. So Dojo is a server. It's not necessarily a server, but it's the UTXO management component. So UTXO meaning unspent transaction outputs in Bitcoin. The Dojo is the UTXO manager that allows for the management of particular classes of UTXOs within certain categories or baskets. So I can categorize transactions. I can put certain outputs of Bitcoin into certain baskets and manage them. I can also verify using a thing called ChainTracks, which is our SPV sort of block header tracking and verification system, all of the data associated with particular Bitcoin transactions. So that's how Dojo and Ninja works. So Ninja is what keeps the private key. So you can have a Dojo server, which deals with UTXO management and output generation. You can request, it's like an engine for generating Bitcoin transactions. It funds them. It has the change outputs and everything like that. And then Ninja is the client-side front-end system. Well, it holds the private key, and it actually signs the Bitcoin transactions. And aside from that, largely Ninja is just an interface into Dojo, so that it's a shell, it's a wrapper around Dojo, but it also does transaction signing and holds the private key, whereas Dojo does not need to have user private keys. So there can be Dojo servers, and then the users hold the private keys, but the server is still able to do UTXO management and manage, user-held funds online to receive funds from other sources, etc. Dojo is also responsible for broadcasting Bitcoin transactions out to the miners via miner API and becoming notified of Merkle proofs when they become available to comply with SPV. So that's how we comply with SPV, is because we actually discover the Merkle proofs on transactions as they happen, and then we anchor everything and verify the legitimacy of these as they come in from the miners, according to the longest chain of block headers, etc., which is tracked by ChainTracks. So the MetaNet client uses the Dojo and Ninja system to manage user funds within the MetaNet context, and then other systems also can have Ninjas and have Ninja private keys to manage funds on a Dojo server, even though they might not be MetaNet clients. Now, when we think of the next layer up, right, what do we want? We now have users and they can make Bitcoin transactions, and there's this way for, if you have a private key, or if you are a MetaNet user who uses the MetaNet sort of private key management system, then, or the one that we use in our MetaNet client, and different clients could do that differently, then you have the ability to now interact on the blockchain, right? What do you want after that? Well, the Bitcoin white paper says no mechanism exists to exchange payments over a communications channel. But the communications channel part of that is kind of left open. So Authwrite is a system for mutual authentication. It enables a communications channel on top of which payments, as well as any other type of message, can be exchanged between two parties, using the private keys of those parties to establish an authenticated link with digital signatures that enable both parties to request identifying information using certificates, and that's what I alluded to earlier. So like, what is my zip code? And then I'm giving you a statement that some certifier attests to the validity of my zip code, and that way you can verify it. So if you trust that certifier who I've provided, then you can verify it, and you can also stipulate which certifiers you want to that you'd be willing to trust, and that way I only provide you information that's actually useful. I can also selectively reveal identity information with Authwrite, but Authwrite runs on top of a MetaNet client, and it uses that interface, that standard, wallet to application interface, to enable a communications channel between users of the MetaNet that relies on this digital signature architecture to allow those users to identify one another and to exchange messages over a communications channel. So that's how Authwrite works. It's a system that sits on top of the sort of MetaNet client. The other thing, though, is that Authwrite is used as an authentication layer for things like Dojo and Ninja. So Authwrite is used in a lot of places. So the Ninja holds the private key, and the Dojo manages the UTXOs for a Ninja. But the Ninja also establishes, using its private key, an Authwrite communications channel with the Dojo, so that the Dojo knows the identity of the Ninja that it's talking to. So that's an interesting component there. Authwrite does not require Bitcoin under the hood. Like, there's nothing Bitcoin specific. It's just a way to establish an authenticated communications channel between users. There's no Bitcoin transactions that need to be created. It's just a protocol for mutual authentication, and that's all it is. So that's the lower layers, right? Now we have authenticated communications channels between users that allow for negotiated identity information, and we have the ability to create Bitcoin transactions and encrypt data and exchange it between users. Those are the lower layers of the system. And then Dojo's sort of features around tracking particular outputs in particular output baskets, and then tagging or labeling rather certain transactions with particular transaction labels, etc. Those are useful things for doing things on higher layers like tokenization. So those are, I would say, the beginnings of the system. And then we moved to actually building on top of that. And now, because we have these lower level constructs, we can create packet pay. So packet pay uses authwrite internally under the hood, and it also uses the MetaNet Client or a Ninja directly. So a Ninja is the thing that creates Bitcoin transactions. So a backend system that isn't a MetaNet Client can run a Ninja and still plug into a Dojo and manage UTXOs for things like creating Bitcoin transactions, or in this case, very importantly for packet pay, receiving incoming payments over a communications channel, such as an API endpoint over HTTP. So packet pay is a system for monetizing APIs that use HTTP, and it uses authwrite for mutual authentication, and it also uses the Dojo and Ninja system either via the MetaNet client or directly to exchange and verify payment transactions in Bitcoin. So users of the Dojo and Ninja system, users of packet pay will pay to make HTTP requests. There is a packet pay client and there is a packet pay server. And the packet pay client will pay, and then the packet pay server will serve the response after payment has been received. So it's a way to establish micropayment-based monetization for various web-based services. So the packet pay server spins up a Ninja, and it spins up an authwrite server so that it can, it's middleware, so that it can authenticate the sender of a transaction. And then the Ninja part is used to receive the incoming payment when the sender sends the payment. And then when you use packet pay.js, you don't even have to configure it if you're using a MetaNet client, because it automatically connects to the MetaNet client running on the host machine. Or if you want to use Ninja directly to send a transaction from the packet pay client, then packet pay.js on the client side, then you can do that as well, and you don't need a MetaNet client. So different ways of architecting solutions on top of packet pay, but that is a system for API monetization. So now we have the ability to pay for anything we want, to establish identity, to deal with applications and permissions. Applications can plug into this system for data encryption and privacy, and users are put at the center by the use of standard and open-ended protocols that deal with all classes of their data. And then we have identity certificates for dealing with all identity attributes as certified by certifiers within the system. So at that point, we want to start moving into the areas of tokenization and things like that. So Tokenator is a system that allows for people to exchange certain tokenized assets using the blockchain. So it's an extensible base class that any sort of implementer can use to support any type of UTXO based, so Bitcoin output based token, and to incorporate that in within a particular application. And so the tokenization features of Tokenator are extensible enough to support any type of UTXO based token. There's no restriction. And the exchange and receipt and validation of that token by the users of the system. And then PeerServe is a way for multiple users to, for two users to exchange messages using a message box architecture that includes the sending, receipt, and validation of tokens, including the validation of SPV information associated with those tokens for full SPV compliance, on top of the MetaNet client and the Dojo and Ninja system, which is generally used for the exchange of those types of messages. However, because it's a message box architecture and because it's open-ended, there's no restriction on the type of data that can be exchanged peer-to-peer using PeerServe. So two MetaNet users who use authwrite to communicate and know who each other are, they can exchange messages either encrypted or otherwise via PeerServe between one another, even if one of them is offline. So I can send a message to PeerServe, and then when the recipient comes online, the recipient will receive and process that message, and then it gets deleted off PeerServe immediately. So that facilitates peer-to-peer communication for things like the exchange of Bitcoin transactions, token data, and things like that. And so that allows for any type of tokenized digital asset to be created, issued, exchanged, received, and validated within the system. And then the final major component of the infrastructure layer here, which is how we can start to define applications and things, would be Confederacy. So Dojo allows for you to track particular UTXOs on a per user basis, because Dojo is sort of an agent of the user, Dojo and Ninja System, within a particular output basket. So for example, I could create an output and say, I want to put this output in my list of diary entries or something. So now I have a UTXO, a Bitcoin token that represents a diary entry, and it's in Dojo. And I could have like 10 of those or whatever. But when I want to start sharing state, right, sharing tokenization state, sharing UTXO state across applications and users in a way that allows for multiple users to interact with one another within the context of a particular protocol or application, then we need a way of synchronizing the state of particular UTXO types using overlay networks. And that's where Confederacy comes into play, because now you have a way of creating outputs, sending them to Confederacy, and then the Confederacy topics, just like Usenet topics in a sense, are there to validate that according to the current state of the overlay, this token is correct, admit a particular new UTXO into a topic, and then monitor that topic so that in the future, if that UTXO ever becomes spent, then it would be removed, or a delegate from the spending transaction would be selected to replace it. So that now there's a way of tracking UTXOs within an overlay. And those systems are very open-ended. So there's topic managers, and each topic manager in Confederacy can manage particular UTXOs within a particular overlay and can enable the tokenization of particular types of data and the constraints under which that can be updated within, just looking at the Bitcoin output scripts that get defined and whether they're valid or not according to the rules of the overlay. And then that gets registered into a topic. Now, Confederacy is actually same with Dojo actually, a federated system. So there's a way of gossiping between different Confederacy instances. So I could run a Confederacy instance that holds like songs and a songs topic, for example. And then someone else could also run a songs topic in their Confederacy. And when a UTXO comes into mine, there's the Confederacy host interconnect protocol that allows for me to discover, the other person's Confederacy, and then they basically synchronize or gossip, just like Usenet does, right? With all of the different updates to UTXOs and state. And that allows for federated hosting of topics, topical data. And each Confederacy will set the rules for, when a new topic is discovered, how will it be paid for, right? So packet pay can be incorporated into Confederacy-based UTXO state tracking, so that there's monetization for the hosting of topical UTXO data within overlays, and then you have lookup services. So within each topic, the final piece is a lookup service that allows for the creation of custom indices and things based on the contents of, again, those Bitcoin output scripts and those UTXOs, so that people can sort and search and find the data they need for the particular application, given the state of the UTXO. So that's how overlays can be built that allow for application state synchronization within Bitcoin applications that use UTXOs properly. And of course, all data within Confederacy is also validated by SPV. So you can't just send a transaction that's invalid because, well, you have to get endorsement from the miners, you have to provide Merkle proofs on the input transactions, and all of that's going to be checked out because just like Dojo does for its transactions, Confederacy also uses ChainTracks under the hood to validate the SPV-based information associated with these transactions. So different Confederacy topics for particular types of data can be defined, and then different applications can create specific use cases for overlays and specific lookup services that implement even proprietary algorithms for finding particular UTXOs within a particular topic. So that's essentially, I would say, how that works. How the overlay system works. I think there was one more thing I was going to talk about. I can't remember. Let's see. So I talked about confederacy. I talked about how state synchronization works between these. Oh yeah. So I said that that multiple confederacy hosts can be spun up and integrated with one another, so that not one single person is the end all be all of what is in a is what is in a particular confederacy topic. Not all UTXOs from all topics are going to be in all confederacy instances, but large ones will emerge that host most of what most people want most of the time. Even though I could still host a small one even at my house and just sync up the things that I might want so that I don't have to pay for it every time I want it. If that makes sense. Just pull in the UTXOs from the larger ones, and then suddenly I have what I need. So same with PeerServe as well. PeerServe being the system for exchanging messages peer-to-peer using a message box architecture. I could run my own PeerServe. Federated networks of PeerServes that synchronize data between message boxes can be implemented, and that way users can exchange data peer-to-peer. And then Dojo, which is the UTXO management system, going back to Dojo and Ninja System for managing Bitcoins and things, as an agent of the user, right? So Dojo has users that represent, people that are going to manage UTXOs using the system, in particular output baskets for outputs, or transaction labeling schemes, etc. And so those Dojo instances are also federated, and there can emerge protocols between them for synchronizing data. And I haven't quite built that yet, but that's what I'm kind of working on right now, is just the federation of multiple dojos. So that there's not one single dojo instance that is the end-all be-all of what is in a user's particular state at a particular time. So the dojo is basically a UTXO backup system for users, and it tracks all the information needed. So I envision that at the end of the day, users are going to run their own dojo and their own ChainTracks to verify all their own SPV information, and then synchronize it with a backup system, so that in case they need to bootstrap up a new device or something like that, they'll be able to have that data available, not just on one backup server, but on a federated network of backup servers who generally would synchronize most things for most users most of the time, as they're paid to by those users, right? Because now the user is the dojo is at the backup server is an agent of the user. So yeah, the federation of all of these systems are possible. It is possible for there to emerge multiple MetaNet clients from different providers, multiple dojos, multiple PeerServe instances, multiple confederacy instances. ChainTracks is just an implementation that connects to multiple sources for block headers, and then pulls down the latest one, checks the chain for the the longest, most proof of work chain, and uses that for SPV. And so yes, all of these systems are federated, and there is no central platform operator that is going to run all of these things. So multiple dojos, multiple all these systems, and that's what happens when you start to define interfaces between things in a standard way where it doesn't change, right? I think that Bitcoin SV should have learned in 2018 that when the rules stop changing, and when you start to have a protocol that everybody agrees on, that maybe from that point, people start to get together and realize the value of certain things. So I've just taken that and extended it a little further. Now I have a protocol for the interface between applications and MetaNet clients. Now I have a protocol for authenticating users called Auth-Right. Now I have a protocol for tracking overlays on Bitcoin called Confederacy. Right? Now there's a method by which UTXOs can be managed, and a standard interface for requesting certain types of Bitcoin transactions within the Dojo and Ninja system. And when these things are fixed, and when the protocols are documented openly, like they are, like literally on my website, you can see all the documentation for this stuff, And when multiple people can interoperate in this way, then we can create a network that is truly peer-to-peer, where there's different operators and different businesses who may have proprietary implementations for certain things, but now they can compete on an open network. And now the user is put at the center, because that's what the meaning of federated systems, that's what it is. So yeah, I'm happy to discuss this in more detail in other videos. Just let me know what you'd like to see videos on. I did have one request for back to Genesis stuff and some discussions around how overlays can be implemented to potentially solve that. So I might talk about different solutions that might emerge in different contexts for back to Genesis. I'm not saying I have the solution for back to Genesis. I don't think there's one solution like what everyone's looking for like that, but I do think that there are ways that it can be addressed, and done so. I would keep in mind that it's an economic problem like any other problem. So maybe I'll talk about that in the future, but this has been a high-level overview of the Babbage architecture and the MetaNet generally, the suite of tools, technologies, standards, and protocols that have gone into making this work. This has been the result of a lot of research and development at the company, Peer-to-Peer Privacy Systems Research, LLC. So we've been doing some work on this stuff for quite some time, and yeah, we're happy to start releasing these things more publicly and discussing more with industry and with the private sector on how this stuff is going to work long term. So thank you.